Well, good morning, everyone. We are grateful that you're with us today to do the webinar for the emergency call taking and dispatch industry here at Esri. We have a really impressive program set for you today, and I want to introduce those people in just a moment. But first, I'd like to just mention that we have from Esri on the call a number of people. Britt Bromley, who is the partner manager for our 911 industry, and Brenda Martinez, our colleague, who is managing this webinar. We are privileged today to have a number of really impressive speakers, but first let me go over our agenda for the day. And John, if you could, there we go, thank you. We will be hearing from John Snap, who is a Senior Vice President at West Safety Services, who will be speaking about the National Emergency Address Database. This is a really exciting series of technology that will be coming to us. West has been spending a great deal of time working on this. John is a Vice President of Technology with West Safety Services, and as the VP over technology, he provides strategic direction and coordination within their wireless group and between other West departments. One of the things I think is really neat about having John on board for this call today is that he is the chief architect behind West's Text to 911 initiative. But more importantly, he served in the wireless industry since 1991 and has been so influential in that in that industry that he currently holds 16 patents. So, John, we appreciate you joining us. At the conclusion of John's presentation, he'll be introducing Nathan Shepard, who is a map exploration lead for Esri, and Nathan has worked with Esri for about 17 years. He's currently leading our software development teams on the ArcGIS Pro desktop products and focuses his time on 2D and 3D and providing interactive exploration through space and time. He also helps coordinate the cross-product 3D initiatives that we have at Esri. Once Nathan has shown some of the things that we're doing at Esri, then we're going to turn the remainder of the time over to Jeff Cohen, who is the senior legal counsel for AAPIKO. And Jeff is also one of those people who has deeply influenced the emergency call-taking industry. He provides strategic guidance on policy, legislation, and regulatory matters for AAPIKO and throughout the first responder network. But prior to coming to AAPIKO, Jeff also served with the Federal Communications Commission and for the minority staff in the House of Representatives in the Energy and Commerce Committee. He spends a great deal of time on Capitol Hill, and we've asked him to share a few thoughts on some of the things that are happening there. I think equally important with the announcement last week of the first state to opt into the FirstNet network, I think it's important just to mention that Jeff was one of the authors of the FirstNet public safety legislation. So to each of you, thank you so much for taking time and spending time with us. I think we have a slide with their pictures that I'd like to show just for a moment, just so you know, and as you're listening to them, who they are. And throughout this webinar, we would invite you to type any questions that you have in the chat window. Britt Bromley will be manning those and trying to answer those as they come in, and as the individual presenters finish their presentations, they'll try to respond to questions that you might have specifically for them. We will actually have Britt review some of those questions at the conclusion of the meeting if we have time, and we'll answer all questions via email if we can't answer them during the webinar today. So again, I thank you for joining us, and we look forward to the presenters and the information that they'll share with us. So John, if we could turn the time over to you, we'll get started.
Absolutely. Thank you very much, Mike, and thanks everybody else for joining this webinar. And I thank Esri very much for setting this up, and the other participants that are on here too, with Nathan and Jeff. So I'm going to talk a little bit about the evolution that we have on mobile location onto 911. And I'm going to start off, and I'm going to talk a little bit about where we are today, and a little bit of the history, just to sort of get a level setting. I'm then going to show some of the major changes that are really going to come in. I mean, I would really say that the changes for what location information and how we're using it, how it gets going to get passed through, we're probably seeing the biggest changes to wireless 911 that are occurring right now, that have occurred since the inception of wireless 911 in general back in '98. So I'm going to talk about what impacts that may have on the bringing of addresses and such into the whole scheme here, and what we may see some changes around that. I'm going to also talk about some exciting areas that we think can change on what I'm going to talk about is locate before route, and I'll say more about that later. And I'm also going to talk about how commercial location may come into 911 and show you the differences between 911 location and commercial location. And then sort of the final piece that I'll talk about, and then that will sort of lead off to a little discussion Nathan will have, is showing that there's the possibility of the Z-coordinate coming in. And if this piece, so the data is going to be available there, and there's some debate on how useful it may be, on how it will come across. But we've got some ideas on if it's there, how that presentation may be utilized, how you may utilize that Z component, and how it may be used. So starting off with, really, let's just sort of talk about what we have today. In wireless, really originally we considered it cellular, but we've really expanded that just to really call it wireless now, because there's so many different protocols that it may go over. What we have is effectively two different areas of location. We have wireless phase 1, and we use that today to actually route the 911 call. Almost all wireless calls today are simply routed based upon the cell ID, the phase 1 location. This location is typically delivered with the call, and I always said it really is just the cell ID location. What we often pass is the address of the cell site or the XY of the sector, or really the centroid of that cell. We're not passing a precise XY location. That originally came out in '98, and then in 2001, we really came out with phase 2, the capability of it. This was using some more precise location to, instead of saying what cell site the call was placed on, what a more precise location it was. Today, that's predominantly done by GPS, but it takes time to be done because of how the flow comes in. The call comes into the network, and then it queries back to the handset to say, can you turn your GPS on? Can you provide a location? Even though that phone may have been sitting there running Google Maps or Apple Maps and having a precise location, the way we do it in 911, we don't utilize any of that commercial location. So it takes 20 or 30 seconds often to get a location for the mobile when it's sitting out there. It's typically using assisted GPS, and this is a little different than what you may see inside of a smartphone of just a straight GPS. There's some difference in the protocols and how it's done. And typically, to get this location in a PSAP, they're going to have to rebid for the data. Sometimes it comes in initially, but typically they're going to have to rebid. So in wireless, we're really just sending an XY across. In the phase 2 is purely an XY location. We may see an address, but it's just a cell site address. In the world of VoIP, we're using an address. Sometimes we have a dispatchable address, but it's one that the user has actually put in. And they may send across the geocoded XY of that address, but it's the user's address, and there's often a lot of risk. Is that really where the user is? Because they've entered it in. I may have, I'm sitting here in Seattle, and I may have put in my address from when I had this device 3 or 4 years ago when I was living in Colorado. And as I moved out here to Seattle, I may have not remembered to update my address. So if I call 911, it would route to Colorado and show my Colorado address. So there's some challenges, but that's sort of what we have with those today. As we're moving forward, what we're really trying to do is bring a dispatchable location or an address for wireless calls, where today we only have an XY or we have an address of a cell site. We're trying to bring a dispatchable location, which is effectively the door the caller's behind, or potentially a nearby address of where they are. I mean, there's some different ways that's being presented by the wireless carriers. There's currently standards work underway that's very far in progress, and there's development work being done on the phones. The standards are being done under 3GPP, OMA, ADIS, majority of this part of the standards work. There's also standards work on how this would be passed down to the handset, I mean, for the handset into the network. So how it really works is when what's being done with dispatchable locations, when mobile phones are making a 911 call, they're going to be queried by the network and will pass some raw Wi-Fi and Bluetooth low energy beacon information down to the network. And it's showing, it's passing down which access points and which Bluetooth beacons are actually visible to the mobiles at that time. It's passing it down to the carrier's network, and their location determining equipment is using a bunch of pieces, is looking to see what access point or Bluetooth beacon may they be close to, or do they feel they're actually within very close proximity of those beacons that they believe they're behind the same door where that beacon would be located. And if they find a close by access point or beacon, they then query into a database called the NEAD. And what the NEAD is the National Emergency Address Database, is the database very much in a way like you might think of the ALI databases for wireline in the past, or the almost LNP database for local number portability. It's a shared national database that has relationships between Wi-Fi access points and Bluetooth beacons and a physical address of where they're located. This is data that's being put in by multiple carriers that are out there. It could be AT&T and Verizon. We may see it come from the ISPs out there, internet service providers such as Comcast or Time Warner. It could be enterprises putting it in. It could be others, but it's a database that has where these locations are. So when the mobile network determines that it has some of these access points, it's going to query the NEAD to see does it have an address for that association. If it does, it's going to bring the location, it's going to bring the address back, and that will be passed on to the PSAP. One thing to think about as we think about the NEAD itself is not a location technology. The NEAD is really a database that shares the information, and then other location technologies that are in the handsets and within the network are querying that NEAD to provide the address. And it's nice because this allows all of the carriers to share this database and not having to recreate this from scratch. The real challenge is, as we think about it, is now we're going to start getting addresses in XY. And where I see this very much as a challenge is, if today we're only really seeing XYs, and many of the CAD systems that are out there are say, if I get an XY in, it's a wireless call, and I'm going to ignore the address because the address is simply the address of a cell site. And if I don't get an XY, I'm going to use the address because it's a VoIP or a wireline call, or my call takers will use the class of service to determine what my response criteria is. But now with this, we're going to be passing a latitude and longitude, an uncertainty, and a dispatchable location. And other times we'll be passing an XY, an uncertainty, and an address of a cell site. So the systems are going to have to really know how to do both and how to plot both, because the XY and the address may come from slightly different sources. You may get the XY and the uncertainty being computed by the GPS that's coming from the device, but the address is being computed by the nearby access point. And they should overlay each other, but they may be slightly different. And both pieces of data are very useful. I mean, the XY uncertainty gives you the area where the GPS believes they're within. It's never a point, it's an area, but this circle or an ellipse or such is the area where the network really believes the caller was within. And then also the address is really where they believe an address where they may actually be. I often think of the XY is really useful to give you the general area where the caller is. That general area could be a circle with only 5 meters of uncertainty or 4 meters of uncertainty, or it could be an area of 100 meters of uncertainty, where the address then tells you sort of which door to go up to behind that, because you may have an XY uncertainty covering a 50-story building, but the address tells you which apartment to get up to within inside of that address. So both of the pieces of information are very useful. As we get this dispatchable location, we start doing it, we're going to start passing new classes of service that come into ALI into the CAD systems. There's a DL1 and a DL2, and it's really the level of accuracy those dispatchable locations get. I think of it very much as a nearby location or the door you're behind type of location. And so we'll have to be able to deal with that. Many of the systems really are going to need to start looking at this classes of service to understand what is meant by the different fields. Because if you get a wireless phase 1, it says you're going to have a location that's only a cell site. If you get wireless phase 2, it says look at the XY, ignore the address because it's a cell site address, but the XY is the most important. If you get a DL1 or a DL2, particularly a DL2, it says your address is dispatchable. We feel it to be very accurate. Look at that first, and the XY is supporting data to show an area that it is beyond just the XY. If the person happens to not be at that dispatchable address, what is the search area you believe they're most likely within? And so we need to be able to have systems that can display both and deal with both, and that the call takers, the telecommunicators, know what to do in that situation. It's not variable. They can't be processing to look at it and say, I need to look at all these variables. They need to be able to take a class of service and have a standard operating procedure that's behind that class of service, as they do today with a wireless phase 1, a wireless phase 2, or a VoIP call, or a wireline call, or even a payphone call if those exist anymore. One thing that we've seen as an issue that's out there a little bit is double geocoding. You may get an XY and an address. Some of the systems are taking that XY and doing a reverse geocoding to get an address, and some of them are taking the addresses and geocoding it to get an XY and displaying both. So we've seen some systems that become confusing because you're converting that data that's already there into additional information, because it's how that's been done in sort of the wireless world. And so that's some sort of considerations to really think about. I think it's also real exciting that you'll start seeing, and this has slight impacts as it relates to mapping, which is really a locate before route. There's some technology that's being looked at now that we believe that in a locate. So today, as I said earlier, all wireless calls are routed based upon the cell ID. We're seeing locations, particularly around commercial location, where that location is actually can be determined quick enough that we may be able to utilize that for routing. And so this makes some changes in the network out there, where what it really is we're going in the past we've defined routing strictly on a static basis based upon cell IDs, saying this cell is going to this PSAP, this cell sector is going to this PSAP, and so on. Now we're going to really have to look at it as the polygon of the PSAPs, which is really done for VoIP and other services now. But for wireless, it creates some policy issues within the PSAPs about how the calls may be routed. And so it's just a little bit of changes, but it can dramatically help things out there, can dramatically remove the number of misroutes. And the area I am in Seattle right now, in Snohomish County, they count that they've consolidated down to 2 PSAPs, but they still say they have over 50,000 misroutes a year, or 50,000 transfers between those 2 PSAPs. And by doing a locate before route, that can be dramatically reduced. We often are starting to see that we actually think we can identify the location down to the highway you're on. So we can know that if you're actually on an interstate or you're on a side road. And so then the calls were in some states where the highway patrol or state police is a secondary PSAP, it's possible those calls can be routed directly to them. So it's really looking at policies that may change around that. A real sort of exciting area is around commercial location. Many of you guys may have seen the HBO session of John Oliver sort of talking about commercial location, why isn't it being used in 911? And there's been a lot of, so commercial location has really advanced a long way. And so the way I separate it is the 911 location was really built specifically for 911. And that was done around 2001. And it was done, it's very reliable. It's very secure, but it hasn't changed since 2001. In a lot of commercial locations, a lot more things have happened there. It's starting to use Wi-Fi location, is using Bluetooth, it's using the magnetometer of the phone, potentially at times with the compass. It's getting speed. It's using sort of other types of inertial sensors sometimes to determine where you are both outdoors and indoors. And because it may run for a sort of a longer period of time as you do Google Maps, you can actually get a more accurate location at the 5 or 6 second time period near to the call than you might with 911 location. And so sort of the idea is, how come Starbucks can find me but 911 can't? It's because they're using commercial location, but 911 is strictly using 911 location. So the idea that we can start, now that commercial location is so widely used with the smartphones out there, we're starting to look at ways of how can we bring commercial location for the use of 911. And so we've seen several companies out there that are doing it now. Google and Samsung have both developed interfaces to provide this commercial location. We're seeing these interfaces can very likely provide ways of doing that locate before route, getting it out there quicker. Depending if the user has location services turned on or turned off on their phone, it gives better levels of quicker location and possibly accurate locations a little faster. But even if they've turned off location services, the devices, when a user dials 911, can turn that back on to make it usable during a 911 call. So this has sort of great capabilities of what we may do sort of around commercial location. The next one I'll look at is really an idea that comes in as ZCoordinate. This one is somewhat controversial. Jeff Cohen, who will talk later, has a different opinion on this one, and I was actually completely in his camp a while ago, but I've started to change my opinion just slightly. And what it is there's a requirement on the handsets to pass an uncompensated barometric pressure through. And so this is really an altimeter. And if you look at an uncompensated barometric pressure, it shows what is the actual pressure in the area where you are right now. And as storm fronts come through and everything else, that changes. For an altimeter to really work, you have to know what a compensated barometric pressure is. What is the actual pressure at a sort of fixed point in a nearby area? And when I mean be nearby, I mean within a mile or two of where the person is. And it could change in a minute or 2 minutes or a 5-minute time frame. So it has to know very precisely what the local pressure is. But if you're able to get that local pressure, you're able to, with most of the sensors of the phones today, you're actually get a pretty accurate altitude above sea level. And in many areas, we have fairly accurate maps showing what ground level elevation is. And so the ZCoordinate could be kind of interesting. It may not start off with being extremely precise, but it may become a guiding factor in some calls. At first, I was really against this because it's like, how are we going to get a ZCoordinate and get this compensated barometric pressure across the whole country? Yes, we have every airport in the country that has weather reporting information is reporting this every 30 minutes or upon real significant changes, but that's not enough. They're not close enough for that to always work. But if you really think about it, you only need a good ZCoordinate where you have a lot of high buildings. And so if we look at the priority of where that is, it may be just the NFL type cities, some of the large cities that are out there. If I look at it in my area, I don't need it except possibly in downtown Everett or downtown Seattle or downtown Bellevue in the Northwest. I don't need it in the rural areas because you only have 1, 2, 3, or 4-story buildings. Typically, you're not having a 30-story high rise. And so, and you also may not actually have accurate base maps of where the ground levels are, but you typically have that much more accurately as we get into denser cities. So what can be done in those few areas is the municipalities or the PSAPs or even the carriers could potentially put out low-cost sensors out there that creates the local barometric pressure, and it does it. And so a few sensors, we're talking in $1,000 or less type ranges, can be put out there in the areas to really give you a compensation for a city. And this may not be something coming from the carrier, but it's something the PSAP type systems, the call handling systems, could have as part of a municipal network to create a local reference network to give us effectively above sea level altitude that then the mapping systems could show above ground level. And Nathan will kind of show a little bit in a second what exactly that could be and how that information could really be utilized. I'm going to go ahead now and pass this over to Nathan, and he's going to do a bit of a demonstration to show what this could look like.
Thanks, John. So my name's Nathan Shepard. I'm with Esri, and I'm just going to run you through a little bit of visualization and interaction in 3D to give you an idea of what it's like to work in 3D and how this content, your 911 stuff, could be visualized in 3D. So we're just going to start off with a common question that people have is, how do I get 3D content at all? Like, how do I get anything in 3D? I'm just using ArcGIS Pro, which is one of Esri's apps. And a lot of cities have building footprints, and you can go 3D really quickly by just saying, okay, I want to take those building footprints and I'm going to extrude them. And in this case, we're just going to make them all 15 feet high. So now we've got something 3D, but it's not particularly useful. If I click on each one of these buildings, we can see we've got some different attributes for them. Each building has some different information, including building height. So we can work with that, and instead of going 15 feet, we can say, you know what, let's use that attribute. And now each building is its own height. So just some polygons with one attribute, and now we get something that looks 3D. We can even add a little bit of symbology. So our buildings also have the number of floors. So this is a 3-story building. You can just sort of bring that up. We can put stripes on the side of it. So now we've got some block shapes, and with 2 attributes, we've got something that's useful and understandable in 3D and can help a little bit. We can do a similar technique for something else that really helps with understanding a view in 3D, and that's trees. So here we have some trees, just some simple representation. Green balls on sticks look like trees. And each one of these trees is a different height. So you might be wondering, okay, where do those numbers come from? Well, LiDAR can give you that information. If we come and look at some of these trees, you can see here's some of the LiDAR points around each of these trees, and how you can use that information. You can write analytical tools that can get the information from the LiDAR and put it onto your tree points, and then just render them this way. So that's very helpful. But if you look at the LiDAR for these buildings here, you notice there's a little bit of extra information in this building. It's got a pitched roof, and again, you can use that LiDAR to generate complex roof types as well. And then from some pretty simple content, just with some LiDAR, you can get a representation like this. We've got, you can learn a lot about an area very quickly in a very simple and thematic way. So that's one way to work with 3D when you're starting from nothing and you're going to have to build all the data yourself. But there are other ways to get 3D content where you don't have to do the work. You can get data from partners and so on, data providers. So here we are in Orlando, and we're in the future a little bit because I've got some Z-aware points here for the 911 calls. And let's come down to a bookmark and we'll look at one of them. Let's go this guy. So these are simulated, these are not real calls, but so this is a drowning and it's way up in the air. So that's kind of weird. Why is this Z way up in the air? It looks like, yeah, there's a pool there, but we're up in the air. We need something to provide us a little bit more context. So LiDAR, even without doing any processing, just provides some context. And from this, we can say, oh, it's probably a rooftop pool, just by turning the LiDAR on and seeing that content. We can come down and sort of get an idea of the whole city from this LiDAR. Now, there's other ways to get content from partners as well. This is called integrated mesh content, and as it comes down, this is a service that's being provided, so I don't have any data local on my machine. We'll wait for the streaming to continue in, and now we get to start to see some more realistic representation. And if we come over back to this area, we can see that's definitely a rooftop pool. We can go down and look at one of the other areas, one of the other reports. So this is a mugging. And the thing that's interesting about this data for me is that you can learn more just by looking at it. So the call comes from here. This is where we think the call came from. And nearby, we've got this sort of forested area. So this is a mugging. Let's say that it's likely that the mugging occurred inside this sort of protected area. The person has left, made the call here. They're probably going to keep walking out into this area, and we could send our responders to meet them sort of out in this area here. Sort of just by visually looking at the content, we can get a better understanding of what it might be like there. Now, the thing that I haven't shown at all yet is uncertainty. So if I turn on sort of a symbolization of that, we can sort of get an idea of the uncertainty. So the size of the disks, the width of this is showing the accuracy of that call based on what we know about it. We can see it's pretty accurate, and we don't need any more information. They're going to be on this path and nearby. But if we go somewhere else and look at another call, if we look from above, we would just know that it's probably in this building, but it could be on the sidewalk around the building. But with the Z information, we can understand it a lot better. So this middle disk is where we think it is. And if you count just visually looking at the data, you go 1, 2, 3, 4, fifth floor. So we think that it probably came from the fifth floor, but it could be the 4th or the 6th, but not the roof. So with our accuracy levels, just by using a symbol to represent it, we can get a better understanding of this call. And remember, this is all attribute driven. So we select it, and we've got the accuracy XY and the accuracy Z. So we can, if the call wasn't quite so accurate, different numbers would be populated in the database, and then we would get more understanding about what we have. And this is all in the database, so I can undo those edits and send them back. And the thing that's interesting here is that when you go to a report like this one, the call could have come from basically anywhere in the top third of this building. That's information that's useful even when you don't know the answer. Not knowing the answer is something that's important to pass that information on. So this is all 3D, but 2D is still useful, and a lot of people are more familiar with 2D, especially when it comes to knowing street addresses and so on. So ArcGIS Pro is a 2D and 3D application. I can have 2D side by side with my 3D, and in fact I can make them work together. So I'm just going to link my views. So now they're together, and if we come in to one of the 2D sections, the map and the scene work together. So I can see, okay, here's the call, I've got the streets and routing information maybe on this view, but I can also say, oh, rooftop pool, just by looking over here in the associated view. So you get the best of both worlds. Okay, and with that, I'm going to hand it over to Jeff to talk about some more information.
Okay, thanks very much. I'll just wait for the slide deck to transition. While we're waiting, I can at least start. Again, I want to thank Esri for inviting me and including me in this webinar, and I want to compliment companies like Esri and West for the work they do for public safety. So what I'll be talking about is a little bit about AAPIKO, and then go into what's actually happening at the FCC in terms of the 911 location accuracy rules that John talked about, and then I'll discuss a little bit about what is happening on Capitol Hill and a little bit about FirstNet. So about AAPIKO, many of you maybe know and are familiar with us, but just to make sure, we're the oldest and largest organization of public safety communications professionals. We're a nonprofit, and our membership is nearing 30,000. And basically our members are employees of state and local government agencies that work in or manage 911 centers or are responsible for public safety emergency responder communications networks. And specific to 911 location, we worked with the 4 national wireless carriers and another organization called the National Emergency Number Association to develop what we called a roadmap for improving 911 location accuracy. This roadmap was delivered to the Federal Communications Commission at the end of 2014, and then in early 2015, the FCC adopted an order that substantially incorporated what we had worked out, and that's the framework we're working on, working under right now. Next slide, please. So going into the negotiations and as part of the FCC's proceeding, I want to talk a little bit about the goals. And to outline this a little bit, what we were realizing is that when it comes to 911 calls and trends, more and more wireless 911 calls are being made from indoors, and more 911 calls are wireless. It's the case that even if you're inside a building and landline phones are available, our instincts as citizens is to reach for our mobile phones to call 911. And therefore, that presents a new challenge because technologies for finding 911 callers from wireless phones were designed to work outdoors. And in fact, until the Commission adopted new rules, they did not have rules that applied for calls made from indoors. So we needed to come up with a solution. Another great trend that we are experiencing in the public safety community is that the needs of public safety, whether it's for 911, for location, or for first responder communications, are starting to catch up with the technologies available in the commercial place. And location is a great example. And the way that the rules changed and what is occurring now is a great example because many more companies are now innovating to help us locate callers, especially indoors. Earlier, John was talking about dispatchable location, and that was a very important definition that we had to develop, and that the FCC ultimately embraced. And basically, as John said, it's the door to kick down. It's as close to the equivalent of a wireline call from inside a building as you can have, apartment 504, that type. The example we use that helps illustrate this is someone placing a wireless 911 call inside an apartment building, and the person passes out due to a heart attack. 911 professionals need to know what door the responders need to kick down, and therefore having apartment 504 rather than a set of coordinates and an uncertainty around it obviously is going to be much more critical to saving that person's life. Also, consumers are expecting that 911 call takers immediately know where they are. That comes from TV and other outlets like that. And we wanted to start to close the gap between consumer expectations and where the 911 networks are. So this is why we embraced on this. And then in addition to the dispatchable location concept, there were other really important developments and goals we set out. One is that there is now a much more objective and expanded testing of these technologies in realistic environments. These environments include all morphologies ranging from rural to urban and dense urban, to include various types of building constructions, et cetera, so that the technologies that we're going to be deploying are tested in as realistic an environment as possible to mimic how 911 calls can be made in real time. Also, the carriers are required to collect live call data and verify that then against the testbed performance indicators. And that's also new because up till now, most of the verification was done by drive testing. And now we're collecting on a quarterly basis live call data and comparing it to how different technologies are performing. I mentioned earlier we wanted to take advantage of the technology innovation that's available in the commercial consumer marketplace, and we wanted a technology neutral approach. There are a number of benchmarks. I won't go into great details in the interest of time, but if you want to learn more, certainly feel free to reach out to me. But basically, the Commission set up a number of benchmarks and percentages of calls with which the carriers are responsible for delivering either an XY fix within 50 meters or a dispatchable location as defined in the FCC's rules for an increasing amount of percent of all calls over the years. The first and most recent benchmark was 40% of all calls, so it includes outdoor, indoor, wherever it's made, by April of this year for 50 meters or a dispatchable location, and that climbs to 80% by April of 2021. John mentioned the Z-axis issue, and we are more hopeful of dispatchable location technologies. The issues with Z-axis are that there are challenges, that they're kind of daunting. You need a lot of infrastructure to be deployed to take advantage of Z-axis technologies. You have to make a number of compensations, not just for the ambient weather, but for the changes in pressures inside buildings because of HVAC. And then you also need building plans. Every building, of course, is different. I gave an example when we did this live of the FCC headquarters. If anyone has ever been there, it has two entrances. They're on different levels, as many buildings can have. And for different reasons or a variety of reasons, the FCC has adopted a very strange way of labeling its floors. So you start with the 12th Street entrance, then you have the main avenue level, then you have the courtyard level. So the point is that it requires these particulars of the buildings to match even a well-compensated barometric pressure reading into an actual floor. But we continue to encourage progress in making sure that Z-axis technologies can actually help. Okay, next slide. So just kind of bring you up to speed on where things are presently and where we're going. There were a number of other requirements in the FCC's order that required a number of reports, et cetera, and the first kicked in February, where the nationwide providers had to submit first reports on their location data that they collected from those 9 live mountain calls. And right now, under the rules, they're provided only to us as AAPIKO, the FCC, and NEAD I mentioned earlier, and a third organization, the National Association of State 911 Administrators. That is because the data is fairly sensitive to the companies, but by providing it to all those, at least at AAPIKO, we certainly are a good watchdog to see how things are trending and improving. They also had to provide initial plans for how they're going to meet the location accuracy requirements and first progress reports. I know that John covered the NEAD or NEAD. Everyone says it a little differently, but there was a privacy and security plan that was required to be submitted to the FCC, and this plan was submitted. It basically was founded on the principle that it incorporates privacy and security by design. 911 caller name and number is not shared in the NEAD. I think John covered that. Also by the FCC's own rules and as pledged by the LLC that was created to run the NEAD, the information will not be used for commercial purposes or disclosed to third parties. And there are a number of controls in place, administrative, physical, and technical, to protect the data and access to the data. Right now, the plan has been submitted as it was required timely to the FCC, and we're awaiting the FCC's action on it. And then, as I mentioned earlier, by April 3rd of this year was that first benchmark where they had to attest and certify that they met that benchmark. Next slide, please. So looking forward, I mentioned the testbed, and there's a lot of detail on this slide, but basically just want everyone to get an understanding and appreciation for how the testing is working, and there are various stages. And it began at the beginning where the carriers tested their own current technologies inside buildings to see how they're performing and almost as a bench line. But then it progresses from different technologies. 2A, for example, were vendor solutions that had commercial form factors and commercial readiness. Testbed and 2A was intended for wide area deployment for indoor wireless location technologies. So they're not necessarily technologies deployed by the carriers, but they're not limited to specific buildings or designed just for illustration purposes. These are, in theory, technologies that could be deployed widely enough to be in use. And then stage 3 would be solutions that are tested under special considerations. It's dependent on vendor readiness, but that's basically to try to tease out new technologies that could have promise going forward. So it will progress along this way, but just to bring it back to the central theme of this webinar, towards the end of this year into the beginning of next year is when dispatchable location technologies will be tested. And at AAPIKO and for public safety, we're very excited about that promise. I'll conclude by just talking, as I promised, a little bit about potential developments on Capitol Hill. First, next generation 911 is something that's often talked about and not yet really achieved in a full and comprehensive manner. And the good news is that on Capitol Hill, and I've been doing this for a number of years, I am seeing, and it's not just me, sincere interest, both parties in both houses, recognizing the need to modernize 911 networks, because frankly, until 911 networks are fully modernized with IP technology for connectivity plus IP-based equipment to serve PSAPs themselves, that's when you could best really take advantage, full advantage of amazing technologies like GIS and others, like smart city architectures, et cetera. And in the Senate, there's a draft bill that's been floated around. It has a lot in it, including a comprehensive definition and a common one for next generation 911, so everyone's working in the same direction. Requirements for interoperability and requirements for employing commercial standards to achieve the pace of innovation enjoyed by consumers, interoperability, and economies of scale. In the House of Representatives, there's been a hearing recently about the topic, a lot of interest expressed, and we're hoping that a bill will emerge in the House as well. So that's all exciting and promising from our perspective. And then lastly, let me quickly talk about FirstNet. Mike had mentioned that one state had opted in. Opt-in basically means, in a nutshell, that a state is choosing through its governor to accept FirstNet's plan for deployment of the radio access network portion of the network in that state. And these state plans have only been distributed, I think it's only about 3 weeks now. But in the meantime, the number of states has grown to 5: Virginia, Arkansas, Iowa, Kentucky, and Wyoming. And the hope is, and certainly from AAPIKO's perspective, that all states opt in. The alternative is if they don't choose to opt in and pursue their own path for building their own radio access network, they have a number of agency and procedural hurdles to pass. And AAPIKO has concerns that even if they do all that, we do have lingering concerns then about maintaining a nationwide level of interoperability. So with that, though, I will turn back the webinar to our hosts, and I thank you for your time.
Thank you, Jeff. Brett, do you have any questions that we need to ask before we talk about a few other things and wrap up?
Yeah, Mike, thanks. We have one, I think it's kind of ties to both John and Jeff. And the question is really kind of getting a little more information on the NEAD and the availability of the data or parts of the database for agencies. So I think I heard that maybe the NEAD is not intended for third parties, but for a a public agency that wants to access the NEAD or download the NEAD or parts of it, can somebody, hoping that maybe somebody could elaborate on what is available to the public and when it will be available?
John, I could take a first stab, and then if there's anything you want to add, this is Jeff. My understanding is that this database will not be available publicly to anybody, but except for the carriers. But the mechanisms would be in place for input of data, because if you think about it, as John explained, the more that the NEAD is populated with Wi-Fi and Bluetooth access points, the more useful and accurate it will be. So there will be secure and trusted and verified ways of the public and other holders of vast amounts of this kind of data to populate the NEAD. But otherwise, the NEAD itself and the information in it will not be used for any purpose other than 911 or shared with anyone.
Yeah,
John?
The only thing I would kind of add to it maybe is that the idea is that the data that's relevant for that call will be passed through. So it's really only the access points that the devices are seeing. That data will be passed through from the wireless carrier all the way down to the PSAP of what addresses of the points it sees.
All right. Thank you. There are some additional questions, but I think we'll take them offline and follow up with the individuals that submitted them. So I thank for the additional questions that were received.
Thank you, Britt. In conclusion, we want to thank everyone who participated today. I wanted to remind you that Esri has invested quite a bit in trying to help the 911 industry, and while we do not provide any solutions directly to the emergency call taking industry, we continue to do the work that we have outlined before, primarily working at the policy level with federal and state and organizations like AAPIKO and others that Jeff mentioned, like NENA and NASNA. But in addition to that, we work directly with our partner CAD providers in making sure that Esri technology is embedded within their solutions and assisting them as they prepare for next generation technology to be consumed into the CAD and then analyzed. In addition, we work with you, the customers, in I guess, placing Band-Aids on issues that you're facing until the technologists in the CAD companies catch up with some of the advancements that we've made in GIS. I would remind you that there are a number of tools that are free to download for Esri customers to assist in address database management. Those can be found in the resources.esri.com website. We will continue to work on web applications that you can download and take advantage of. And of course, we believe very strongly that we all will need to make a migration from two-dimensional analysis of data into a three-dimensional world. And the efforts of Nathan and his team will benefit you directly if you'll start to take advantage of those tool sets that are available with your licensing. We would remind government entities that there is special pricing that takes into account shift work and other things that are available to you. And John, if you could just give me that last slide, I wanted to mention a couple of additional things and give people time to grab a screenshot of that. One is that our next webinar for the industry will be in October on the 25th. But we would remind you that you can go to the Public Safety Webinars page and see all of our past webinars, including webinars for the law enforcement industry, fire, and emergency management. So a place where you can really dive in and see specific kinds of disciplines. Also, a reminder that we will be at AAPIKO. We have, I believe, 3 presentations that we'll be doing there, and we look forward to meeting with Jeff and his team in Denver. And again, we will also be in IACP in Pennsylvania in October for the International Chiefs of Police Conference that will be held there. We have links to AAPIKO's websites. And if you reach out to me in this email here, if you'd like to talk directly with Jeff or with John or Nathan, we can connect you there. With that, I'm going to just go around the horn quickly and give each of our participants a chance to add anything additional, or we'll close this off. So if I may start with John Snap.
I just want to thank you very much for the opportunity to talk a little bit about this, and thank everybody else for being as part of the webinar, particularly Nathan and Jeff on doing this. I think we're in a time where there's some exciting changes coming with the location, but everybody just needs to be aware of what it is and what changes to the networks and procedures are going to need to occur.
Thank you. Nathan, do you have anything additional?
Nothing too much. Thanks again for inviting me. It was great to present some information. I'm a big fan of an advocate of 3D and 3D GIS use cases, and I think this really fits in. And hopefully everybody's less scared of 3D now and looking forward to actually tackling this. I think it's a really good problem to tackle.
That's great. We appreciate your efforts. And Jeff, anything from your perspective?
Yes, thanks, Mike. I could just add that it might be of interest to the audience that at our conference coming up at that time, AAPIKO is going to be releasing a major report that we've been working on for over a year. It's entitled Broadband Implications for the PSAP, and the intent is to serve as a major starting point of conversation about how 911 operations will be impacted by broadband and IP technologies from a technology, cybersecurity, governance, operations, training, and workforce perspective. So we're very proud of this, and we'll be launching it at our conference, but it'll be available to anybody online in mid-August. Thanks.
Oh, that's great. I know there's been a lot of anticipation for that. Thanks to everyone. Thanks to each of you who took time out of your schedules today to join us, and we'll look forward to seeing you in October. Have a great evening, or day, I guess, depending on which part of the world you're in.
Thank you. Bye.